Good morning, 8th graders. Welcome to Algebra 1. This is Unit 1, Lesson 6. Thank you for coming into class with your microphone muted, your camera on, and you're going to raise your hand. Thank you for when you need help. Please turn off your camera if you're going to the bathroom and use the chat box appropriately. So, I want to start off today to announce that if you don't see it, I actually post these daily announcements every single day. As you can see, yesterday's was Unit 5 Applications of Solving Equations, and in these daily announcements I always provide the video that you can watch. I always try to provide the link directly to the assignments, any practice that you have available, and I always post my intervention period link that you can click right there and join. So this daily announcement will always provide the review over what we did that day, and it's just a really good place for if you missed that class, or / if you just want to be like, oh, like, hey, what did we do again? You can always check there, so you can see especially the video or the recording of the lesson and the assignment for that day. It's a really good tool. Please make sure that you're checking that announcement out every single day. Next up, you just watched a video about this, but I really wanted to showcase that when you go to your class notebook here, that in your class notebook that you're gonna have these 5 little subsections. You can actually delete all 5 of those. You don't need any of those, but specifically only those folders you can delete. Some of you might not see them, and that's because I've already deleted them myself from your folder. It's just I can't do that for 130 students. Next up, you're going to see with everyone's name, that's like your folder. Sorry, Jocelyn, I'm in your account. Then you're going to see this Unit 1 Solving Equations. Within there, you're going to see exit tickets and student handouts. Your exit tickets is actually where you're going to find your assignment every single day. But secondly, your student handouts, you're going to always find the entire lesson handouts in there. For example, you have your do now here, and if you were to keep scrolling through the pages, you would see your practice, you would see your homework, you would see every single page for this lesson, and it's all in your class notebook. So if you want to practice in it, then you can go ahead and do that, and if you want help, I can help you out, and you just need to tell me like, hey, Mr. Manion, I was doing the student practice, can you go check it out for me? And we can talk about it. So this will be available for every single lesson, and it's in your class notebook. So let's get on with today. Today we are solving multi-step equations with special solutions. Bulldogs will be able to solve multi-step linear equations, including those with special solutions. So here's our do now. Everybody, I have these 3 questions. What I want you to do is take a second, pause the video, and go ahead and answer these 3 questions either in your Algebra 1 student workbook, your spiral, on a piece of paper, or just take a second and think about it. I'm going to post the solutions, so make sure you pause the video. Your solutions are coming in 3, 2, 1. Here are the solutions. Go ahead and check and make sure that your work is correct and that you kind of had the right ideas. If you have any questions, you can raise your hand and I'll be able to help you out. Now, our guided practice. So Clarissa, Skylar, and Fatima solved the equation below. Clarissa claims that x equals 10 is a solution, or makes the equation true. Skylar claims that x equals -2 makes the equation true. And Fatima claims that x equals 7 makes the equation true. We want to know who is correct. So if we go ahead and work with Clarissa, she claims that x equals 10 is a solution. So that means that everywhere I see a 10, I'm going to replace, or everywhere I see an x, I'm going to substitute a 10 in its place. Just like so. If we go ahead and simplify, this is going to be 3 times 11 minus 5. equals negative 10 minus 2, and then 4 times 10 gives us 40. We keep going. 3 times 11 is 33. Negative 10 and negative 2 make negative 12. And finally, if we take 33 minus 5, we get 28, and if we take negative 12 plus 40, we get 28. Both sides of the equation are now 28, and this is a true statement. So, everyone, what does that mean for Clarissa? Clarissa claims that x equals 10 makes the equation true, and she is correct. X equals 10 does make this equation true. Well, let's check Skylar. She claims that x equals negative 2 makes this equation true. So, I'm replacing or substituting every x with negative 2. So we're left with negative 2 plus 1 is negative 1. Negative 2, remember, makes this a positive 2, minus 2. 4 times negative 2 gives us negative 8. 3 times negative 1, back on the other side, gives us negative 3. 2 and negative 2 make 0, and so we're left with negative 8. And negative 3 minus 5 is negative 8. Whoa. So, Skylar claims that x equals negative 2 is right, or makes the equation true, and she is also correct. So far, like, 10 is a solution and negative 2 is a solution. But Fatima claims that x equals 7 makes the equation true. So let's check Fatima then. 3. That was 7, right? Yes, x equals 7. So replace every x with a 7 now. Seven plus 1 makes 8, equals negative 7 minus 2. 4 times 7 gives us 28. 3 times 8 is 24. Back on the other side, negative 7 and negative 2 make negative 9 plus 28. 24 minus 5 gives us 19, and negative 9 plus 28 also gives us 19. So when we substitute x equals 7 in the equation, Fatima is also correct. Why is this so? It says that every single person is correct: Clarissa, Skylar, and Fatima. So let's check that out. What we're going to do is I'm first going to rewrite the equation, and then I'm going to solve it so we can see something that happens. Our equation was 3 times w plus 1, or x plus 1 actually, minus 5 equals negative x minus 2 plus 4x. Alright, let's see what happens when we solve this equation. When we solve, I'm first going to distribute to get 3x plus 3 minus 5 equals negative x minus 2 plus 4x. From here, if we combine our like terms, I can combine a 3 and negative 5 to make negative 2. I can combine negative x and 4x to make a 3x, and then bring down that negative 2. So what you see, or what we find, is that once both sides are simplified, that the right side of the left and the right side of the equation are equivalent. They're identical. Both the left and the right sides are identical once they are simplified. And this right here is a true statement on its own. So, no matter what the x value that we substitute, we're always going to get a true statement. This is what we call an identity. When an equation works out or is simplified and both the left side and the right side are the same, we call this an identity. I'm going to go ahead and erase this part, and I'm going to write that out. So, here's what we have. When both sides of the equation are simplified, and the coefficients of the variable are the same on both sides, and the constants are the same, on both sides. The equation has infinitely many solutions. The answer, or well actually, so when it has infinitely many solutions, this is called an identity. The answer can also be all real numbers. So if we were to break this down, basically what this means is that if the equation, let me highlight this in a different color and larger, if the equation, once simplified, has the coefficients of the variable and the constants the same, so basically I'm saying if the equation is the same on the left and the right, then the equation has infinitely many solutions. There are too many solutions for us to even count. X equals 10 may work, x equals 7 may work, x equals 2.5 may work. There's infinitely many solutions. Then, once that happens, we call this an identity. That's the name. We would say, oh, that's an identity. And we know that when we see an identity, that we can answer the question by saying that the solution is all real numbers, because any number, any value of x will satisfy or make that equation true. Let's see example 2 now. If we were to solve this example, again, I would start by distributing as needed, and we see that we are left with 2m plus 5 on the left, and on the right 5m minus 35, because we're multiplying when we distribute, minus 3m. If we go ahead and combine our like terms, I get 2m plus 5, because nothing combines over there, but we get 5m minus 3m, so that's going to be another 2m, and then minus 35. Okay, so you can see, so far, we have an equation, and we simplified, and it's not the same, so we already know this is not an identity. Well, once both sides are simplified, if we were to try to isolate the variable, for example here, if I take away 2m to bring all my variables to the left side, so that means I need to take away 2m there, well, we see that we are left with 5 comes down on the left, but 2m minus 2m, that brings us to 0. On the right side, 2m minus 2m also brings us to 0, and so I get negative 35 left over. And so I get 5 is equal to negative 35. Now, the variable term is eliminated, and the equation this time yields a false statement. It's not true like it was last time whenever we simplified, whenever we tried to solve the equation. So take a second and look, and like, why is this problem confusing? How is it different than the last one? Well, once we simplified here in this step, notice that the coefficients of x, or your variable, were the same, but my constants were different. And so if the coefficients of your variable are the same and they are eliminated, it's always going to yield a false statement. It doesn't matter what x is going to be. So if it's always going to yield a false statement, that means that it's always going to be not true, right? It's always going to be false. That means that there's going to be no solution because of the false statement. So how do we interpret these findings? From this last example, we can see that not all equations actually have solutions. Some equations have what we call no solutions. And this happens when both sides of the equation are simplified, and the coefficients of the variable are the same. But this time, the constants on either side of the equal sign are different. Where we get a false statement. So it means that the equation has no solution. This is what we call a contradiction. So let's break this down. Basically what I'm saying is, once you simplify the equation, right? Simplify means that you no longer need to distribute and you no longer need to combine like terms. Once you've done both of those steps, then, and you can see that the coefficients of the variable are the same, but the constants on either side of the equal sign are different. So we gotta have the coefficients, the variables look the same, but the constants are going to be different. You might have a 2 and a 5. They just can't be the same. Then you're always going to end up with a false statement. And so when you end up with a false statement, like 5 equals negative 35 in that last example, then we know that the equation has no solution. No value of x can make that equation true, no matter what value you substitute in there. So when no value makes an equation true, we call this a contradiction. And a contradiction, it's called that because it's contradictory. It doesn't make sense whenever you take a look and you say, oh, 5 equals negative 35, haha. No, that's not true. So we call that a contradiction. So let's move forward. Let's solve each equation and see how each of these line up. So in the first one, notice that the coefficients are different and the constants are different. So let's see what's going to happen when they're both different. If I go ahead and draw the river, let's go ahead and solve. My first step would be I want to have all the constants on the same side. So I'm going to take away 3 on both sides, and so I'm left with 9x equals 7x plus 12. Now, since, again, we didn't need to distribute or combine like terms, I'm applying inverse operations. I am going to now move the variables all on the same side by applying inverse operations. And we get 2x is equal to 12. Oh, well, I like the way this looks because now we can take the last step and divide by 2, and so we get that x is equal to 6. There we go. Now, from here, we would take the 6, and we can substitute to make sure that that's our answer. So this is going to be 9 times 6 plus 3 equals, what was the other side? 7x plus 15. So 7x plus 15. 9 times 6 is 54. 54 plus 3 is 57. 7 times 6 is 42. 42 plus 15 is also 57. So we know that 6 does make the equation true. 6 is a solution. What about example 2? I'm going to do the same by drawing the river. Not in blue. I like it in black. There we go. And from here, we do not need to distribute, we do not need to combine like terms, but as you can see, the coefficients of the variable are the same, and the constants are different. So when these are the same, and the constants are different, let's see what happens. If I take away 2 on both sides, I'm left with 9x is equal to 9x minus 14. Well, I need to get all my variables on the same side, so let's take away 9x on both sides. I'm left with, well, 9x minus 9x is 0 equals 9x minus 9x is, again, 0, but then I have that negative 14. So I have a statement that says 0 equals negative 14. Is that true or false? This is a false statement. What is it called when we have a false statement? This is called a contradiction. And what does a contradiction mean? Well, it means that this equation has no solutions. No value of x can make this equation true because the coefficients of the variable were the same, but the constants were different. So let's check example 3. Started out the same. Now notice the equation is simplified because we do not need to distribute and we do not need to combine like terms. And notice that we have the coefficients of the variable are the same and the constants are the same. What happens when both the constants and the coefficients of the variable are the same? So we can start by adding 2 on both sides. And we get 9x is equal to 9x. Well, if we were to take away 9x on both sides to make sure that the variables are on the same side, we get 0 equals 0. Huh. Well, that is a true statement, but I just really don't like the way that looks. It looks confusing to me. I'm going to try this another way. What about this? What if instead of taking away 2 on both sides, let's take away 9x on both sides this time. Let's do that step first and really try and get all the variables on the same side. So take away 9x, well, that still leaves me with 0, but I can bring a negative 2 down. I can bring this negative 2 down, and oh, no, that ends up with 0 again. So I'm left with an equation that says negative 2 equals negative 2. So no matter what, I mean, I get an equation. Is that true? Is it false? It's a true statement. So what is it called when it's a true statement? So I'm going to go ahead and write that. So this is a true statement. And what is it called whenever we have that true statement? That's called an identity. An identity means that there's infinitely many solutions. Or we can say that the solution is all real numbers. So these were the three types of examples of solutions or equations that you can see. Here on the left, you can see that we will end up with equations that have unique solutions. This is what you've been working on solving for the past few days. Today I'm introducing no solution equations, and I'm introducing infinitely many solution equations. So those are going to be the three types that we can solve here in algebra. Everyone, here is a quick summary. Again, you can have unique solutions, you can have no solutions, or you can have infinitely many solutions. Go ahead and pause and read through this as needed. This is a quick summary over the key points of today's lesson. Student practice. Alright everyone, during this time you are either working in your workbook or you have a piece of paper that you're writing these equations down and you're solving it there. I want you to take this time to pause the video and to solve each of these problems, and then I'll post the solutions. Again, you should pause the video here. Alright, make sure that you pause the video. I'm showing you the answers for these 4 questions in 3, 2, 1. Here's the solutions. Remember, your directions are without solving, determine the number of solutions. So you can look at the coefficients and the constants and determine how many solutions there are. Question 2, fill in the blanks for the following questions. Here you're creating equations. There are multiple answers. Answers will vary. Make sure that you pause the video. Solutions are coming in 3, 2, 1. Remember, if you have any questions, you can raise your hand. Question 3 says solve the following equations by showing all steps. So you're solving the equation and you're telling me what the unique solution is, if there are no solutions, or if there are infinitely many solutions. Pause the video. Your answer is coming in 3, 2, 1. So the first one is a contradiction. There were no solutions to that first problem. Solve the following equation. Let's keep it up. Your solution comes in 3, 2, 1. So we saw that this equation was also no solution, which was because it was a contradiction. Solve the following equation. Everyone, you've paused the video. Your solution's coming in 3, 2, 1. This one was an identity, which means that there were infinitely many solutions. Solve the following equation. Keep it going. You're a hard worker. Your solution comes in 3, 2, 1. Solve the equation. Make sure that you pause the video. Your solution is in 3, 2, 1. Now it's time for our exit ticket. Everyone, you can find the exit ticket as an assignment in our class. There are 3 questions. Remember, please solve these 3 questions either on the exit ticket itself. You can text or draw. You can also write down the exit ticket on another piece of paper, and you can take a picture with your work and paste it directly on top of the exit ticket that I provided. You are going to transform the equations into a simpler form or solve them. State what type of solutions you expect them to have, and give them a brief explanation of why you expect these solutions. 2 parts. What type of solutions and why. Everyone, there are 3 questions. It's time for your exit ticket. Let's get going. Thank you for this lesson in algebra.